Everyone. Welcome to our webinar. Really nice to see so many of you online. It'd be great if people could just put in the chat that they can hear us and see us. That would be really helpful. So we have in the webinar today Matt Morse, former chair of the Legionella Control Association, also a long-standing advisor to us in Infersens, and who will talk to you today about myth busting some of the things you might have heard and not heard about remote monitoring technology. With me on the other side of the screen is Colin Payne, co-founder and CTO of Infersens, and really the sort of the brain behind our remote technology we've been developing over the last 6 years or so. And myself, I'm Jana Voigt. I'm the CEO and co-founder of Infersens. The way we run the webinar today is Matt will give a talk and talk to you around remote monitoring technologies. We will then at the end share a couple of sort of good, bad, and interesting scenarios we found and where we felt that we were able to help some of our customers. And then we will have the floor open for questions. Feel free to put your questions into the chat on the side, and we will pick them up after the end of our session. So without further ado, over to Matt.
Thanks, Jana. I'll just try and share a window. 1 second. There we go. We've got a PowerPoint presentation. So good afternoon. Welcome to Myth Busting, Remote Monitoring for Legionella Risk Management. Whenever I think of myth busting, I normally think of these two guys. I did think about possibly finding a beret and a false beard for this session, but I thought that would probably be a bit too much. But there are some significant myths around remote monitoring out there. I do get asked a lot of questions around this in my day-to-day work as a consultant and with various organizations that I work with. So I've thrown a few into this presentation. Myth number one, ACOP L8 says ... It was only this week, was it last week? Might have been last week. Somebody sent me a piece of risk assessment paperwork, and it said ACOP L8 says horticultural misting systems XYZ, and it doesn't. It really doesn't at all. The wording isn't in ACOP L8 at all. It's in HSG, and it's very much a sort of a guidance piece if this and this and this applies. So the first myth here, ACOP L8 tablets of stone says this. It really doesn't sometimes. So let's look at a few parallels. Move slightly to one side away from remote monitoring for a second. What does the ACOP say about the frequency of showerhead cleaning? If this was a live presentation, I'd say, put your hands up, tell me what you think. But obviously it's not. So I'll throw some examples up on there. 6 monthly. Most people think, no, it's not 6 monthly. Of course it's not 6 monthly. Quarterly. Everyone says, yes, quarterly. Based on inspection, based on the rate of fouling. Yeah, definitely. The more savvy people, quarterly, based on the rate of fouling. But that's not quite right. That's not what ACOP says at all. In reality, ACOP says absolutely nothing about the frequency of showerhead cleaning. If we want to know anything about what ACOP says in terms of cleaning anything, it's all in paragraph 59E. And it says, maintain the cleanliness of the system and the water in it. It doesn't say anything about going there quarterly. It doesn't say rates of fouling. It says, keep it clean, keep the water in it clean. So it's pretty simple stuff. So if we're working to the ACOP in terms of showers, this parallel, it doesn't necessarily mean we've got to clean the shower at all. What it means is we've got to keep it clean. It's got to be clean. So if we clean it quarterly and it still remains dirty, we've failed. So really, if we're talking about what's in the ACOP, we need to be aware of what's actually in the ACOP. Myth number two, remote monitoring is not compliant. That's always a great one. Not compliant with what? And everybody always points to the guidance. Not compliant with the guidance. Well, the guidance, by virtue of its name, is guidance. It's very difficult to be compliant with something that's there to guide. So let's have a look at some of that. In my other work, I get asked a lot of questions, usually around standards. I was involved back in the day, a small part in the creation of ACOP L8 2013 and HSG 274, not HGG, interestingly. Slight typo there. I also work on a couple of British standards committees, and I was heavily involved in writing the LCA standards. So I'm pretty familiar with some of this stuff. And I was also involved in the group that wrote the Water Management Society guidance on remote sensing, remote monitoring. So I get quite a few questions, and quite a few of those questions are about remote monitoring. So here's a few examples of the sort of statements that I sometimes see. My client won't use remote monitoring as it's not permitted under the legislation, which is fantastic. So the legislation, we'll talk about in a second, but if you think about things like the Health and Safety at Work Act, things like COSH, things like Management and Health and Safety at Work regs, they don't mention the word Legionella, let alone the monitoring for Legionella. The HSE don't allow for remote monitoring in the guidance. Again, that keyword guidance, it's there to guide. We'll have a look at exactly what it says in a minute, but it's probably a bit strong to say we don't allow something because it's not or is in the guidance. The authorizing engineer insists on manual monitoring because that's what the guidance says you must do. Using the word guidance and the word must in the same sentence is a little bit of a stretch for me. Okay, so let's look at that legislation. When we talk about compliance, compliance is with the law. It has to be with the law. That's obviously the legal requirement. We have Acts of Parliament. Generally, we're speaking about the Health and Safety at Work Act 1974. Sometimes, some scenarios, we're talking about the Health and Social Care Act. Regulations, statutory instruments, we're talking about COSH, we're talking about Management and Health and Safety at Work regs, and a few others. Now, we don't have the word Legionella, as I said, in any of those documents. Legionella comes out, I think it's in the H40 as a class 2 pathogen, which is related to COSH, but it's nothing about control in there, nothing about monitoring. Then we come down the hierarchy, we come to ACOPs. So L8 is the one in case in point here for Legionella control. So yes, that very specifically is about Legionella control. Here's a copy of the document here. It's a fairly thin document. You turn it that way, it almost disappears. That's because it doesn't have an enormous amount of detail about the hows. It's mostly about the whats. So what does it say at the front of the approved code of practice? We've got this wonderful special legal status statement. The code has special legal status. If you're prosecuted and it's proved that you didn't follow the relevant provisions, you have to show that you've complied with the law in some other way, or the court's going to find you at fault. So that's an inverse burden of proof. You've got to do this stuff or prove that you did equal to or better than. So that's pretty heavy. And then we come down to the guidance. And as I say, the guidance is there to guide. HSG 274 in 3 parts, mostly concerned with HSG 274 Part 2 today. Various British standards, BS 8580 for Legionella risk assessment, 7522 for Legionella sampling, the LCA code, the LCA standards, those all talk about Legionella very heavily. Obviously, it's the Legionella Control Association. The Water Management Society guidance. So Water Management Society guidance is there for various things, but specifically in this case, for remote water monitoring. So lots of guidance exists, but guidance is very much guidance. You don't have to follow exactly what it says. It's a good example to follow. It's a good bit of advice to do what you need to do to comply with what the law says. Following the ACOP helps you comply with what the law says you must do. ACOP monitoring is a term that often gets thrown around. We're monitoring to the ACOP. Now, when we talk about schemes of control, we talk about monitoring the scheme. What it really boils down to is paragraph 65C, the last bit on the bottom of that slide there. Monitoring to ensure the treatment regime continues to control to the required standard. So the monitoring itself is not actually doing the control. The control is being done by the physical things that you are doing to that water system. The monitors make sure that you're actually still doing it, still achieving it. So when we talk about the actual controls, the first control we're going to talk about is temperature. And come back to paragraph 59 of ACOP L8, paragraph 59A, avoiding water temperatures between 20 and 45. So that's really where we start to talk in the ACOP about some actual substance, some actual things that we can try and achieve. So the principle of control is temperature in the ACOP. It doesn't talk about how we monitor it. It doesn't talk about how we look after it. It's just purely what those temperatures need to, well, in reality, not be. We need to avoid between 20 and 45. So the detail is definitely not specified in ACOP L8. Second control then. So the first one was temperature. The second one, water movement. So paragraph 59B, avoiding stagnation. So the principle here is keeping water moving along through the system. The picture there is a hot water return. It's commonly recognized when these things fail, they're going to be stagnant, and that stagnation will allow time for bacteria to grow, including Legionella. But the detail of how we monitor that stagnation or avoid that stagnation isn't specified in ACOP. There's nothing in there about that. So manual monitoring, the traditional way of going and putting a thermometer under a tap, it's not in the law, it's not in the ACOP. So we're all familiar with doing that kind of stuff if we're in this industry, but we often think that because it's what we do, it's what is required, and that's not always the case. So it's not in the law, it's not in the ACOP. Those are the bits that have that legal standing. So if it's not there, surely it's got to be in guidance. The guidance we're talking about, HSG 274 Part 2, possibly we're looking at HTM 0401 if we're in a healthcare setting. The guidance says, store your hot water at greater than 60, distribute at greater than 50. Pretty simple stuff. Greater than 55 if it's healthcare. That translates within some of those guidance paragraphs to if we take a temperature at an outlet, it should be at least 50 degrees within a minute, or a 55 if it's healthcare. So again, lends itself to putting a thermometer under that outlet or measuring a temperature in some way from that outlet. Recirculating loops of hot water should be greater than 50 all the time to make sure that we've got circulation, make sure we've got movement, and make sure we've got temperatures that are unfriendly to Legionella. Cold water should be stored, should be distributed less than 20. Simple stuff. This is how we are avoiding our 20 to 45 degrees that the ACOP says we should be avoiding. And it translates there to an outlet, gives us a time thing on there of 2 minutes, less than 20 within 2 minutes. Very simple metrics. Monthly, doing those sentinel, annually doing a wider thermal profile. So everyone's probably fairly comfortable with that if you're in this world of Legionella control. Very, very simple stuff, very easy to do. And it's something that people get a little bit hung up on as what the given is that you must do this. So let's have a look at the differences then. The differences between manual and remote monitoring. Well, manual monitoring normally uses an immersion probe, sometimes uses a contact probe. These are both contact probes in the picture. Somebody's taking a return temperature on the right-hand side there. Actually, it's on both of the return temperatures. One just happens to be pushed through the insulation, one's pushed directly onto the pipe. So we could use a thermometer that goes under the tap, under the flow of water. We could use something we push onto the pipe. Remote monitoring generally uses contact probes. There are some areas where we might use things like thermometer pockets in pipes or thermostats on bits of kit, that sort of thing. But we're not necessarily going to be running temperature probes under a stream of water. We're normally relying on contact probes with the remote. So that's one difference. But the real fundamental important differences between the two are firstly the frequency, and secondly the change that happens when we measure. So if we were to take manual monitoring and we put a thermometer under a tap once a month, we've got one reading. If we have a remote sensor that takes, for example, maybe once every 15 seconds, if it takes a temperature every 15 seconds, we're going to have 178,000 measurements in a month. So there's a pretty significant difference in the amount of data and the frequency that it's done there. Changing from measuring. So if we take a tap, take an outlet, we open it, we put a thermometer under, we are changing the value that's in there by taking the measurement. Seems pretty simple, but it really accounts for one of the big differences between manual and remote monitoring. Manual monitoring, you probably get a good temperature because you're running the water. So the system is capable of achieving a good temperature. If you were to somehow get that temperature without running the water, the chances are that wouldn't be the same number. Okay, so here's a question. Would a duty holder be expected to use remote monitoring? Is that, do you think, an expectation from the regulator for a duty holder? Second question, could there be a situation where remote monitoring is more practicable than manual monitoring? Practicable meaning take all of the sacrifice, all of the cost and putting it on one side of the scale and all the benefit on the other side of the scale. Do they balance out? Is it more reasonably practicable to take remote monitoring as the option? Here's an example. This is a hospital environment. This was in the investigation following a death in hospital from Legionnaire's disease. And lots and lots and lots of subordinate and tertiary hot water returns. The system was far more complex than it could have been, arguably should have been. A lot of those were above ceilings, and they're in patients' ensuite bathrooms, so almost impossible to get into easily. And sometimes months went by without them being monitored, without being checked. So in this case, remote monitoring is probably the reasonably practicable option, the option that's going to give you the goal, it's going to achieve the goal of actually seeing what's in those pipes. So should remote monitoring there be the expectation? It's a question mark on the end. That's something to consider. So think about your own scenario where you're looking at a building that you're monitoring or that you run. Should remote monitoring be the expectation, or is it something that's an extra, a nice to have? Myth number 3 then. There's no guidance for all this stuff, no guidance for remote monitoring. Well, there is some guidance. There is Water Management Society guidance here. So this is in 2 parts. This was written, the people on the front there are acknowledged, but this was written as an industry group with HSE involvement. The reason being it takes quite a lot of effort and a lot of commitment for HSE to get a piece of guidance out independently. It's a lot more convoluted than for an industry body like the Water Management Society to do it. So the Water Management Society did this really to help further the industry and get some information out there about this more quickly than the HSE could. But HSE were involved. So this comes in 2 parts. The piece on the screen there is part 1. They're both free downloads. So you're able to download these and read them without being a member, without going behind a paywall or anything like that. So part 1 is considerations for implementation. And part 2 is what it all means, what the data means. Part 2 is definitely the difficult bit. Part 1 was pretty simple. So let's have a quick look at part 1. What does it say? Well, it tells you really how to choose a system. And it gives you a series of questions to ask suppliers. And some suppliers are very quick to jump on the bandwagon and say that this is where their system deals with all these questions, how it answers all these questions. But the title on there, Initial Guidance for End Users, it's for end users, this particular piece of guidance. So it's really for somebody buying one of these systems to know, to be knowledgeable, to ask the right questions of suppliers. It also talks in this guidance about evidence-based actions, and I'll come back to that a little bit later. It lays out the pros and cons, what's good about remote monitoring, what's potentially bad about remote monitoring. And it also talks about data and how we manage data. And the difference between 1 or 178,000 points of data is fairly significant. So it's pretty obvious that we need to have some kind of data management on this. Otherwise, it very, very quickly become unmanageable. So here are a few examples. There's a long, long, long list of pros and cons. These are the ones I picked out. So the pros, this stuff is real time. It gives you real time information about what's going on. It's not what happened last month, it's now. It lets you get to difficult places. Now that could be geographically, or it could be just physically within the building, within void spaces, within difficult to reach areas. It confirms use. So if water is moving and temperature changes, you're reasonably confident that you've got some use there. Now, it's not foolproof, and later on we'll see some examples of where it can be fooled. But fundamentally, if you've got a sensor that tells you that water is moving, it's really valuable. It allows you to do evidence-based decision making. So if water has moved, you haven't got to go and move it yourself. You haven't got to go and do flushing because you think it's stagnant. You know it's been used. So evidence-based decision making, very, very powerful. On the other side of the balance, the cons, sometimes these systems can have physical technical issues. So sometimes you will see sensors that says offline or cannot get a connection with the base or whatever. Buildings tend to be made of fairly substantial materials in this country. So they're concrete, brick, stone and so on. Very, very difficult to get radio signals through. It still requires some manual work. So just having a remote sensing setup does not actually get away from things like shower head cleaning or tank inspections, that sort of stuff. And this is one of the real sort of rub points for remote monitoring sometimes. There are difficulties in setting limits. Where do you set the boundaries? What does good look like? What does bad look like? When we wrote this guidance, we were all very much agreed on what bad looked like. That was easy. Bad is bad. And we were all reasonably comfortable with what very good looked like. but it's what acceptable looks like in the middle that's the struggle. And we'll talk about that a bit in a second. And then the last point on here, data overload, the number of points of data. And so many datas, so much data really does sort of overwhelm sometimes, alarms, alerts, and so on. But the best software is going to filter this stuff and it's going to prioritize it. But you need to be very, very careful where you set your limits, where you set your alert proformas, because if an alert goes off, you've got to make sure that somebody can actually deal with it. I stole that idea for the data thing from Tom Laffey, so credit to him. He's the Star Trek geek. Myth number 4, the results are all meaningless. Okay, so we've got our remote monitoring on one hand, we've got our manual monitoring on the other. The manual monitoring, go in, you put a thermometer on the tap, you take a temperature, it gives you a yes, no, this is good, this is bad. Remote monitoring gives you 178,000 points of data. Chances are they're not all going to be good. Chances are some of them are going to be bad. But are they bad? The point there, the results are meaningless. I don't think they are, but a lot of people might get a little bit confused with those results. So the Water Management Society Guidance Part 2 concentrates on interpretation and management of data, the difficult bit. So this took a little while because it's the what it all means piece, and we came back to the number 42, the answer to the world, the universe, and everything, or life, the universe, and everything. If you're familiar with that book, it's if you want to know what the answer means, you've got to understand the question, and that fundamentally is where this sits. The data is the data. It's not meaningless. It's just telling you what you're asking. You just need to understand what you're asking to put that in context. So this particular piece of guidance comes up with a few pieces of advice. The first bit here is no firm and fast metrics, or not very many. It's not as simple as HSG 274, where greater than 50 is good, less than 50 is bad. It's not quite that simple. It does reaffirm the fact that the duty holder, the user, has responsibility for their own scheme of control. This is not something that can be outsourced. It's not something that can be subcontracted to a software provider or a sensor provider. The user has to take responsibility for the metrics that they set. Now, that's not new. That's exactly the same with the old, good old-fashioned manual monitoring. It's just that there are things in there you can easily follow within the guidance. Have to do a little bit of joined-up thinking of your own when we start to look at remote monitoring. It reaffirms the fact that the compliance piece is with the law. The compliance piece is not necessarily with guidance, it's with the law. The guidance talks about how remote monitoring, if it's going to be used, should be considered as part of the risk assessment, and the sensors should be described in the written scheme of control. So how you assess risk, how you deal with the risk, how you deploy sensors, how you manage those, all of that should be part of the program, not something that's dropped on top. And one of the modern things that's coming out of remote monitoring these days is risk assessment, risk management as a ongoing process. So instead of doing a risk assessment and it being a line in the sand, a point in time, and you come back and review it later as a single one-off static process again, okay, not single, but you know what I mean. It's an ongoing process. So as data feeds in, the risk can be visualized in real time. Alerts, then, what the data means. Well, the alert side of things, we really didn't put in this is good, this is bad. What we tried to do in this guidance was put in the thought process. So there's a couple of principles here. First of all, we can't put these limits in stone because they're different for every system. They're different for every type of system setting, system users. But what we can say is that we've definitely got some fixed expectations where we can set a little bit in stone. We've certainly got some less fixed expectations. And how we set those really depends on the people that are using the system, their vulnerabilities, their susceptibilities to Legionnaire's disease and other diseases, the usage of the system, how often it's used, what sort of system it is. And all of that, really, it comes down to the duty holder. It's the duty holder's responsibility to determine what they want to do. The guidance is intended to give them the tools to be able to do it. So when I said fixed expectations, what I was talking about was bits of the system that we can reliably expect to deal with a fixed goal. So things like calorifiers, we're putting heat into them, so we can set a limit of 60 and be relatively comfortable that that's something that should be achievable. Hot water circulation, all of the hot water circulation should circulate, so we can be relatively comfortable. It should be at a certain metric of temperature, 50, 55. That works. Cold water tanks. We shouldn't ever see a cold water tank go above 20, so that's another one that we can use as a relatively fixed metric. So those are our fixed expectation pieces. Last point on here, be wary of run times. One of the things that came up in the discussions when putting this guidance together was a lot of duty holders, a lot of building users, a lot of building people that are in charge of buildings like to turn off hot water at night, turn off hot water circulation, turn off the calorifier heat source. Fine if you're doing manual monitoring, because you just don't monitor during those times. If you've got remote monitoring, it gets to be a bit wearing when every night you get an alert saying your hot water's got a bit cold because it goes off at 6 p.m. or whatever it does. Going off at 6 p.m. isn't necessarily part of going to increase the risk profile, as long as it comes up to temperature the next morning, or it does all it needs to do in terms of anti-stratification and so on. But it's just a characteristic of the system. So when you set alerts, when you set your expectations, you've got to be quite wary of what the run times are for that particular system. Now, this is the difficult bit, the less fixed expectations. So cold water pipework. Cold water pipework is probably going to reach ambient temperature relatively quickly within a building. It doesn't matter how much insulation you throw on it, insulation is only ever a time delay, so it can get to ambient temperature. Outlets. Outlets by their nature are not going to be flowing, they're not going to be moving all the time unless you've opened them. So when you're not opened them, when they're closed, we're going to see temperatures probably get to somewhere close to that 20 to 45 degrees. So the duty holder has to decide what's acceptable, what's not acceptable. But I would very much doubt in any control scenario we're going to be concerned with being with between 20 and 45 for a short period of time, or for a period of time that's deemed within the normal usage of the system. Because that's what happens at the moment in every water system, regardless of whether we're looking at it with remote monitoring or not. Now, I said the bad was quite easy to determine. There's no movement of the water, and we're sitting at a gross temperature. That's obviously pretty bad. That's two of the metrics within paragraph 59 of ACOP L8. So straight away, we're going to be struggling to control Legionella growth. But the question then is how much movement? How much movement do we think is good? And that's setting dependent, it's system dependent, and to a certain extent, it's really got to be a little bit of system by system determination of what good looks like, what bad looks like. How often do we need to achieve temperature? If you think about the old manual monitoring setup, kind of once a month it had to achieve temperature. In reality, if it only achieved temperature when you ran it, it probably wasn't a very well-performing system. But the question there, how often does a system need to achieve a temperature that's desirable? Okay, myth number 5. There's no proper guidance for this. So the implication being that stuff from people like the Water Management Society isn't proper guidance. Something needs to come from HSE, something needs to come from government. So let's have a quick chat then about enforcement, how enforcement works. Regulators will look at what's being done to control whatever risk it is. They would then form what you would call an initial enforcement expectation. So what would be expected to be being done if the risk was being controlled adequately? Now, the way in which they form that opinion is from established documents. So they will look at the guidance that's out there, they'll look at the standards that are out there, and those don't necessarily come from HSC. They can come from all sorts of places. So they will determine then whether there's a risk gap between what they expect to see and what they're actually seeing. And if there is a risk gap, then they will take action. That's where enforcement happens. So the Water Management Society guidance for remote monitoring has this status. It is established guidance in that respect. The HSE, as I said, also contributed to that guidance, so they're well aware of what's in it and what it means. Okay, myth number 6. It's all about temperature. And we do tend to get a bit hung up on temperature with Legionella control because we can measure temperature. It's quite difficult to measure whether or not something's been left and not flushed for weeks or months or years. So here's another question that might be a bit contentious. Are there any water systems out there that can comply with L8? If we think about L8, paragraph 59A, it's talking about avoiding temperatures between 20 and 45 degrees. Can we think of any water systems that do that all of the time in every part of the system? I can't think of any. If you think about mixing valves, downstream of the mixing valve, it will usually be between 20 and 45. If you think about cold water systems at the terminal ends of outlets of branches, they will get above 20 degrees in the cold water. They'll get below 50 degrees in the hot water. So very, very quickly, parts of the system will fall out of compliance, in inverted commas, with ACOP L8. So Legionella control can't all be about temperature, because most buildings will have areas that don't comply with the temperature requirements of ACOP L8. So it can't all be about temperature, otherwise the morgue would be stacking up with bodies, people dying of Legionnaires disease all the time, which doesn't happen. It's still a relatively rare disease. So we need to go a little bit beyond temperature. We need to think about water movement. Now, measuring temperature is possibly one way in which we could infer that we've got flow. So we could measure temperature, and if temperature changes, we've got some sort of water movement. Now that can be fooled by static temperatures. So we can see temperatures remaining steady, but we've definitely got water flow. But because the stuff that's coming in is the same temperature as the stuff that's coming out, we don't see the flow. You can also be fooled the other way, where we get a temperature change, but we don't necessarily get any flow because it's just a rapid ambient or something similar. But if we can reliably measure flow of water, and we've got a really good metric for looking at paragraph 59B. So that's about stagnation. So where can that take us? So first of all, let's take a history lesson. Let's look back a bit. This is the Tay Bridge. This is up in Scotland. Well, I say it's the Tay Bridge. It's not the Tay Bridge. It's a big hole in the Tay Bridge because the Tay Bridge fell down in 1879 in a storm while a train was going across it. So that was a bit unpleasant for the people that were on the train. I don't think there were any survivors at all. So the train came off the bridge, and the opinion really when they built this bridge was that the braces were strong enough to take the weight of trains, to take the wind shear that was on this bridge. You can see the diagonal bracing on the horizontal part of the bridge there on the right-hand side, these all cross braces. So the opinion was that those braces were strong enough, but they didn't have any evidence. They'd not tested them. They hadn't tested them to destruction. So that's a fairly significant sort of parallel to what we do with flushing. We think that buildings may or may not have had use in these outlets, so we flush them regardless. We're working with no evidence. Turn it around the other way, sometimes we believe those outlets do have flow, and they might not. So again, we're working without evidence. So in the Tay Bridge disaster, the Kirkcaldy Testing Works, which sounds a bit Scottish, it's actually in London, it's in Southwark, they analysed the broken parts and they tested some of the surviving bits that hadn't been broken. And this is the building. If you ever go down, I think it's Southwark Street on the south bank of the Thames. Quite an interesting building. It's still got the testing apparatus in there. It's now a museum. But they determined the actual strength of the bridge. They determined that the bits that the designer thought would break at about 80 tons were actually breaking at 20 tons. So straight away, because they'd made an assumption about the strength of these parts, they'd got it wrong. They put people at risk, people died. Similar sort of thing with flushing. You make an assumption that these outlets have been used or not been used. You're not acting on evidence, you're not acting on data. So this is the sort of carved stone lintel bit above the door of this place. Facts, not opinions. So in one of my other roles, I deal with assessors that look at evidence from people, and they're all independent contractors. And one of his limited company was called Facts, Not Opinions, because he was interested in the facts, he was interested in the evidence, not what people thought about things. Okay, so the evidence-based approach then, if we know an outlet's been adequately used, we obviously don't need to flush it. So straight away we've got savings, we've got benefits there. On the other side of the coin, if we know something hasn't been used, we can direct resources. So in that respect, knowledge is power. And that knowledge saves us the money, saves us the energy from heating the water, pumping the water, those sorts of things. It saves us the time for somebody going out there to do the job. So it's not all about temperature. Water movement's going to play a pretty significant role. Now, in the past, if you say, has that been flushed? It's very, very difficult to determine that. And this is the sort of stuff that we often saw, rooms packed full of junk and a set of records that said, yes, it's been flushed every week. You think, really? Has that really been flushed every week? Did you take everything out? Did you then flush it? Did you put it all back? Did you reinstall the cobwebs? It doesn't seem very likely. But when we're faced with something like this, okay, that's not a particularly clean set of basins in an industrial complex. How do we know those have been flushed? They're not stacked up with crap. There is some evidence they might have been used. It's very, very difficult to say. What about the highest risk outlets within building showers? How do we know if those have been used? If the shower cubicle is actually empty of stuff, and it looks like it could be plausible, it could be used, how do we know? And the answer is, for sure, we don't. So if we look at remote monitoring data, the latest and the best types of sensors that can look at flow duration as well as just temperature, they can give us some reassurance that systems are being used. The red figures here, the orange boxes, the green boxes, they tell a story. So the green boxes down the right-hand side are saying that we've got a reasonably good, a satisfactory flow duration. So it's getting several hours of flow across the course of that measuring period. Despite the fact that the temperatures on the left-hand side, some of these are 25.5 degrees. So straight away, that's not compliant with ACOP L8 paragraph 59A. But it is getting good flow. It's getting good usage. So if we consider what a manual monitor's building would be like, that might well be sitting at exactly those temperatures until we run the tap and take the manual temperature monitoring measurement. As soon as we take the measurement, all of a sudden we've got a compliant building. So we need to be very careful how we treat this data and what compliant looks like, or what we consider to be compliant. So this is the same outlet as the average temperature during the water flow there. So you can see that when that was opened, it was around about 16 degrees on average, 16.7 on the figures above. So you can see that that is performing. That building is performing well, and it's performing just as well as any building that might have been run during manual monitoring. Last couple of slides then. Water savings. We have some potential if we work with evidence to save water. These are some slides. I pinched these ones from Infersens, but the one on the left-hand side there is an estimate on the amount of water it takes doing temperature monitoring by running taps and putting the thermometer under, and the amount of water it takes from doing flushing for Legionella control. And on the right-hand side, we've got a very similar looking graph with a very similar sort of sized slice of pie. And that's the water saving target from DEFRA, Department of Energy's Fisheries, whatever it is, Agriculture and so on. But this is the expected non-household consumption targets that they're putting out there. And if we can tighten the amount of water that we potentially, I hesitate to use the word waste, but the water that gets used from temperature testing and gets used from flushing requirements, then we will be a long way along to meeting that water saving target. Possibly. And we could be doing that without compromising Legionella control, which is critical. Okay, the final myth then, which I don't think I'm going to answer this one. Flushing is the control for low or no use outlets. If anyone's got an opinion on that, perhaps you should put that into the comments. Maybe we'll address that in the questions at the end. Okay. That's it from me. So I'll hand back over to Jana. And I'll stop sharing my slides. Over to you, Jana.
Just switch myself back on. Thank you very much, Matt. That was a really great overview. So maybe just to talk a bit more around some real case scenarios we found, where really it's, for me, I think the take home message is the combination of temperature and flow in remote monitoring is really what's the important piece, I think, for that to be interpretable. So this is the only sort of plug I'm doing. So what we've developed is a flow and temperature sensor, which can do both. So it measures temperatures all the time on the pipe surface, but importantly, it also tells you about flow. How that looks and how you get the data, I will show you some examples now. And is this one? Right. So I've picked out some scenarios. I can't show you a proper, I hope you can see that okay. I can't show you the front end of the dashboard because obviously I want to keep that confidential with customer information on there, but there's no customer information on this. But this is to give you an example of a sensor which is located on a cold water main supply. It's only a 15 mil incoming, so it's not very big. And it's just to walk you through it. This is sort of a 1 day graph, 4th of March. Red is temperatures on the left here. Red is our sort of danger zone of temperatures because it's obviously a cold water pipe. And below the 20 is the sort of the tidy zone. What you see here is the temperature reading our sensor sends through on the pipe surface, which changes. And the blue bars here, you can see these are when we have detected flow. So you can see a nice correlation in this instance of sort of temperature changing on the pipe and there being flow happening in this particular pipe. It's a really good example. The one thing I would say though, and I get asked that a lot, is why can't you just monitor your flow at the incoming mains? Well, actually, I know exactly in this day, we have had showers being used 3 times, but of course it doesn't appear here as a solid 20-minute or 10-minute shower, which obviously we shouldn't be using, but because this incoming feeds into a cold water supply tank. So it gives you actually no information around duration of usage of water at an outlet within the building. It just tells you when water has been flowing into the building, into the cold water storage tank. But I think it's a very nice example. So temperatures are always below 20 and there's really nice correlation. Now, this is an example of a hot pipe. And I think what this is really showing you is a difference. So you see 50 degrees is the cutoff. So we want to be above 50 when we have flow. These are flow events. And you can see in operational use, we have flow, but the temperatures don't necessarily reach above 50. Now, the reason is this is actually a mixer tap. And to get a lot of draw on your mixer tap, you have to really put it all the way to the right-hand side onto full hot to pull enough hot from your 2 pipes feeding that tap to get your sort of really hot water coming into it. So it's happened here. And that's because I actually did a temperature test on this particular tap. So I really tried to push it and see if I did my temperature reading in the minute, can I get to the 50 degrees? But actually in operational use, when normal people would use it, no one would push it all the way to the hot end of the tap. So they would obviously not actually get sort of hot water coming through the system. So having the combination of the 2 there available to you is really quite helpful because you actually understand sort of what that means. And if you look at a lot of the time, your pipe, as Matt pointed out, is sitting at obviously sort of, lower temperatures, room temperature in that particular setting. The last scenario is a shower. Now, this is a shower. It's fed by a hot pipe, and this is a flow event of that shower. Really clear, been used for 7 minutes. Temperatures go down, great. Now, people are saying sometimes you can just infer whether there has been usage or not just based on the temperature change. Well, I've shuffled back a few days. That very same shower had this profile of the temperatures. You can see a very long period where actually that pipe was sitting below the 20. So it's a cold pipe feeding an electric shower. It would have been probably considered that might have been flow because clearly it's below. Why would you have cold temperatures? Actually, it wasn't used at all that day. So this, I think, is a good example where having a combination of flow and temperatures actually gives you information on whether or not this particular shower is safe. And, is that safe? That shower now, if you switched it on, even though it hadn't been used, it was sitting above 20 for a period of time, then went below 20. It could be because it's in a cold ceiling void. We don't quite know why it's going cold. It's very interesting, but clearly something's happened, but not at the shower head. So I guess these are sort of some scenarios I want to sort of show you of sort of the good, the bad, and the intriguing. of where we think really sort of technology which provides you with flow and temperature reading in a combination can come. I think just to reassure you, though, we don't expect people to look at this kind of detail all the time. And I've put the sort of the customer thing so we don't share any confidential data. But really, the idea is that you have a dashboard where most of this is already analyzed for you in a RAG status, as sort of Matt pointed out. And then when you have challenging environments, you have the opportunity to look into the detail. And I will stop here, and we can now start taking any questions. Nat, do you want to come back in for that?
Yeah, can you hear me okay?
Yes.
Yep.
Great. Yes, we have quite a few questions and one that has been upvoted by a couple of people. I'll bring it onto the screen and I'll read it out as well. What would be the recommended calibration frequency for sensors? And is there any correction applied to the sensors to account for the heat conduction differences via different pipework material? And just to say very quickly before you answer that, we did say 45 minutes. So if you need to leave, you can do, and we'll be sharing the recording after the fact. But please go ahead and answer.
Matt, I think maybe you start with that.
Okay, no problem. There is a bit of research published by Bizria. It's pretty old now. It's AG 494. It's been withdrawn, but it's never really been replaced. And it talks about how sensors and different pipework materials work and play nice together, or conversely, don't play nice together. So it is recognized that if you put a sensor and you try and do a contact measurement on an insulating piece of pipe, something like plastic, it's not necessarily as good as if it's something like a conductive piece of pipe like copper. So there may well be, or there will be, heat conduction differences between different pipework materials. So that's one part of the question. The second part of the question about calibration. There is a piece of LCA guidance out there on calibration. So you go to the LCA website and look at standards. It has a section there on the right-hand side where it's got information on calibration. It does mention calibration of remote sensors. And what it really speaks to is you've got to be sure that these things are giving you an accurate representation of what's going on. And provided it's doing that, then that's satisfactory. So it's not necessarily taking all the sensors out and sending them away to a lab and getting them factory reset and put all back again. It's about going around, taking some validation measurements with a calibrated instrument and making sure that what it's telling you is still correct. If you look at the Water Management Society guidance, it also talks a little bit about calibration. It talks about the fact that a lot of the times when these sensors are giving you duff information, it's very obviously bad because the sensor has, for example, come away from the pipework, or the sensor has completely stopped sending data, that sort of thing. When they do start to drift, when they do start to move away from truth, in terms of Legionella risk control, that's not necessarily the absolute critical, because a lot of the times what we're interested in is movement as well as just a bland temperature. So that's the calibration piece. In terms of the offset between what the sensor outputs as a number and the true value that's going on inside the pipe, there is some room here, and this is talked about within the Water Management Society guidance, potentially for if you know that your hot water is always 2 degrees lower on the sensor than it actually is coming out of the pipe, calibrated by 2 degrees. In terms of sort of legal compliance for doing that sort of thing, if you've got a written scheme of control that lays out your approach for Legionella management and for Legionella control, then you just detail it in there. You say, we know that this does this, and therefore we've taken this step, and now we are confident in the number that we're getting out of the back of it. So hopefully that answers all those bits of the question. If Jana, Colin, you've got anything you want to add on there?
Yeah, only that it's very interesting. We have had those findings as well, and I think it depends on how the site is sort of set out, especially if you have a site which where your temperature goes to ambient temperature very quickly. We've just done a sort of calibration at one of our sites, and interestingly, we found, so we measured with our sensors as well as 2 reference pipe touching thermometers and inflow. And we found, surprisingly, a 5-degree difference on the hot pipes between what's the inflow temperature versus the pipe surface, and around sort of 2 to 3 degree temperature for the cold ones. So I think it's quite important to take some of those readings, because otherwise you end up having obviously lots and lots of ambers and reds on your dashboard, when actually turns out your water inside your pipe is perfectly compliant with every flow, so qualifying flow event. Thank you.
If you're happy, we've got a couple more just now, and I'll pull the first one onto the screen. And the question from Matteo is, why do the ACOP temperatures differ from the guidance temperature? Is it acceptable as long as the water remains above 45 degrees within a minute?
Okay, that's a really interesting question. The numbers that we work with in terms of what temperatures Legionella grow at, what its ecological niche is, they go back to a bit of research that was done in the early 1980s, and it's the same bit of research that we pull out some great figures like, at 50 degrees we kill 90% of Legionella in 2 hours. At 60 degrees we kill 90% within 2 minutes. That kind of stuff all comes out of that piece of research, and that really talks about the nuts and bolts of what Legionella will grow at. What it doesn't really do is give any safety margins, doesn't give any working allowances for a system. Now, because manual monitoring is the way it is, you're taking one measurement and you're hanging your hat on it for a month potentially, then these safety margins are very important. Once, and this is an opinion, once we come to looking at things much more closely, I would argue that those safety margins become slightly less important. But really, it's down to the appetite for risk of the individual duty holder that needs to determine what they want to do. But fundamentally, the science, the paper behind this says 20 to 45 is the zone of temperature that we're concerned with Legionella growing at. The ACOP takes that figure. HSG 274 and HTMO 401 then build on that figure and build in some safety margins. So that's the reason it's a safety margin.
Anything to add, Jana or Colin? No. Great.
No,
we'll take one. Cool. We'll take one last question, and I'll just pull that onto the screen. This question is from Rob, and he's asking if only Sentinel outlets are remotely monitored along with the calorifier flows and the installation has no tertiary or secondary return loops installed, would this, in your opinion, be acceptable to meet the requirements of a control scheme?
Partly. so I suppose the answer is no. But yes, it would, in terms of the routine things that you do to make sure that, classically we talk about sentinel outlets, it's the weather vane, it's the thing that's telling you how the rest of the system is blowing. But what we're really talking about here is that regular monthly check on the sentinels. Yes, it would replace that. What it won't replace is what the guidance recommends, which is to do representative outlets once a year. And that might be somebody coming around with a good old-fashioned manual thermometer and just checking a representative proportion more than the sentinels. How many that is depends on how complex the building is. But in answer to the question, most of it yes, all of it probably no.
Fantastic. And that's all the questions we have.
Okay, fantastic.
Brilliant. Well, thank you very much.
Thank you, everyone.
Yeah, thank you, Matt. That was excellent.
Yeah, Nat, do you want some closing remarks?
Yeah, just very quickly to say thank you for your time, everyone, and we will share this recording after the session. Yes, if you have any other questions at all, please send them our way at inquiries@infersens.com. If it's something specific for Matt, we can direct his way as well. But thank you again, and have a lovely day.
Thank you. And thanks, Matt.
Bye-bye.
Bye.
Bye.